question 24, and we've got a fairly complicated looking setup. It can be sorted relatively quickly simply by looking at the equation for what we're looking at here. So we're looking at how the EMF is going to be affected if we start messing around with things. Specifically, we're going to mess around with the flux density. The flux density is going to go from B to 0.5B, so we've halved the flux density, but we've also increased the angular velocity, which has gone from omega to 2 omega. So we've doubled the angular velocity and we've halved the magnetic flux density. Now, and this becomes really simple when you look at the equation that gives us EMF. So the EMF, and it's one of the most protracted equations that we see in A2 physics, it's BAN omega sine omega t. There we go. So that's our equation for the EMF. It's BAN omega sine omega t. The maximum value that the sine omega t can take is the maximum value that any sine of any function can take, which would be 1. So the maximum EMF we can generate is going to be BAN omega. Now, B is half, A hasn't changed, N hasn't changed, and omega has doubled. So I've halved that, doubled that, total effect. The maximum EMF is not going to change. So we're looking for a graph that peaks at the same values of max EMF as the original one. So the original one maxed at 10 volts. This one is going to have a maximum EMF of 10 volts as well. So that's our first thing. The second thing is, how is it going to affect the frequency? Because of course when you're looking at a graph that looks a little bit like this, there are two things you think about. You think about the amplitude of the thing, and you think about how squashed or how wide it is. In other words, what is the frequency of the thing? And we're told that we're going to be rotating it twice as fast. If we're going to rotate it twice as fast, we're going to expect to see twice as many peaks in the same amount of time. So the original graph, just over a period of 10 milliseconds gave us that. If we're going to be getting a situation where let's try proper English this time. If we're going to have a situation where the angular velocity is doubled, then we're going to see an entire waveform for this. So instead of just half a waveform, we're going to see an entire waveform in the same amount of time. So in other words, we're looking for a graph where the peak EMF hasn't changed, but we've squashed it up so that it's twice as frequent. So we're going to see a whole waveform in 10 seconds. That's going to lead us towards graph B for question 24.